So we're reviewing for our test that covers sections 6.1 through 6.5. The first section on your test, so basically each slide is labeled and it goes along with your test. So like the first section on your test is the first slide on the review. The second section is the second slide, that type of thing. All right, so to order ratios least to greatest, we have 5 ratios that they give us. 15 to 4, 19 to 5, 53 to 15, 4 to 1, 18 to 6. And it says to order them least to greatest. Well, just as a reminder, whenever I order something least to greatest, I have to compare them all in the same format. Now, while they're all the same ratio, their values are different. A denominator of 4, a denominator of 15. And you know, they all vary. So in order to kind of level the playing field and see their true values, I want to convert them to a decimal. You guys remember this? Okay, so convert it to a decimal, and no, they won't. They'll all be different decimals. So the first one, and really for all of these, to convert a ratio to a decimal, I divide the first number by the second number. So 15 divided by 4 would give me the decimal version of that ratio. All right, what would that be? 3.75. Okay, it is 3.75. Okay, 15 to 4. So what about 19 to 5? What would 19 to 5 be? All right, so we just punch it in our calculator, 19 divided by 5, and we get 3.8. Go ahead and convert the last 3 ratios. Okay, so 53 to 15 becomes what, everybody? What would it be? 3.53 repeating. Okay, we all made these conversions, right? We're not just waiting for the answers. Okay, so 4 to 1 is just 4. 18 to 6 is just 3. So now that we have all of our conversions, we can clearly see that what ratio is the smallest? 18 to 6. And when we write it in our final answer, it must be in the original format. So I use my conversion to determine which one's the smallest, and then in my answer, I write it in the original format. All right, so 18 to 6, and then what's my next smallest? 53. Okay, and go ahead and finish writing them in order least to greatest. Okay, so what's the next one? What's the next one, guys?
15 over 4.
Okay, so we got 15 over 4. 19 to 5, and then 4 to 1. 4 to 1. Any questions on ordering ratios least to greatest? All right, so like I said, first section on your test tomorrow. All right, next one, it says write the ratio in simplest form and in all 3 ways. All right, so we look at the ratio, and if it's already in simplest form, we don't have to rewrite it. We just write it in the other 2 ways. If it's not in simplest form, I have to first simplify it and then use that value for the other 2. Okay, so you decide, does it need to be simplified? If it does, simplify, then write it in the other ways. 2 options here. We can either write it as a mixed number, and of course I put the answer up there, but we can either write it as a mixed number or as an improper fraction. And I've got this question a lot, so I want to make sure I address it. Okay, now 8 1/3 is correct if I'm talking about writing my fraction in proper format. We say to write it as a proper fraction, it would need to be a mixed number. However, in order to keep it a ratio, I must leave it improper. Okay, so again, this is a question that comes up often, so I just want to remind everybody, we don't write these as mixed numbers. We keep them improper, and then we write it in the 2 other formats, with the word to and with the colon. All right, and those are my 3 formats for writing a ratio. Any questions on that? All right, who got that right? 25 to 3. Okay. All right, questions? If you got it wrong, do you see where you went wrong? Okay. All right, here comes the next one. All right, so solve the proportion. 5 over 12 equals x over 36. I chose this one specifically because really any of the 3 methods would work for this problem. I could use equivalent ratios. There's a missing link. I could use algebra because the variable's in the numerator. And then I could use cross products because cross products works every time. Now, I know that I've kind of tried to push you in the direction of using cross products because it does take out the debating, oh, well, which method do I use? Because I know that that one works every single time, but you can use the other methods also. All right, it really doesn't matter. I'm not going to care as long as you show your work. All right, if I look at the problem, I should be able to clearly tell what method you used by your work. All right, so go ahead and finish solving this. So raise your hand if you used equivalent ratios. Nobody?
Is that what you do with the parentheses?
Yeah. Okay, raise your hand if you used algebra. Anybody multiply by the reciprocal? Raise your hand if you did cross products. Okay, that should be everybody else. All right, so cross products does seem to be the most popular method, which is great. All right, now, if you use cross products, do you have this equation written next to it or underneath it? You must, and this is what I'm going to call the cross product equation, you must have this step in order to get full credit on your test tomorrow. Because here's what I've seen a lot of. I've seen a lot of just this part, the 180 over 12. That's all they write, is 180 over 12. And they do the rest of it mental math. And while you're still going to get the correct answer, you're not showing me all of the steps. You're not showing me all the work. And I understand that solving proportions isn't necessarily the most complicated thing we've done all year, but you still need to show the work. So anyway, all right, so 180 over 12 and x equals 15. Very good. Now, if you had filled in, that's what the red arrow is for too, to make sure you show that equation. If you had filled in with the missing link, okay, or equivalent ratios, you could just write a 3 in parentheses between top and bottom number, and that's acceptable. When I look at that, I say, oh, they used equivalent ratios. No problem. There's their work. If you used algebra, you should have multiplied both sides by 36, and I should see that step, okay? And then you can cross reduce if you want, 1 and 3, and then you would still get 15. So that just kind of gives you an idea of the type of work that I'm looking for, depending on the method that you choose to solve. Okay, got it? All right, everybody good? Who got that right? Who got 15? Okay, good. So solving proportions. Now, what if I ask you to tell whether or not the ratios form a proportion? All right, so here's your ratios, and now tell me whether or not it forms a proportion. Okay, so how do I tell? How do I tell? Do I just say yes? I use cross products. I use cross products, okay? I don't cross reduce, I use cross products, and when I multiply them, they don't come out to the same total. So no, they don't form a proportion. All right, if they come out to the same number, then the answer would be yes. So now we're getting into 6.4 and 6.5, these corresponding angles and sides. Now, I want to help you hopefully make a connection here, all right? However many sides are in the figure, that's how many pairs you're going to have. So in this case, how many sides are in a triangle? 3. So that's how many pairs you have. How many pairs of angles and how many pairs of sides. So if you had a 5-sided figure, how many pairs would you have? 5 and 5. All right, so making that connection will help you not forget a pair. So you know if it's a 4-sided figure, you should have 4 pairs. Okay, so go ahead and give me the 3 pairs of angles and the 3 pairs of sides, and don't forget to write your symbols. So your angle symbols and your side length symbols are very important. The angle L and what other angle?
P.
Angle P. Should be angle M and Q. Should be angle N and R. Should be side LM and
Side
PQ. MN and QR and LN and PR. Very good. All right, who got them all? Who got them all? All right, so hopefully very easy question to do well on tomorrow. All right. Okay, so now using similar figures. All right, so it's really important, guys, that you try to do this ahead of me. Okay, so last hour I had a little bit of a struggle with basically getting you to try it. A couple of students were still just kind of confused, but If you at least attempt it on your paper, I can help you maybe figure out where you still might be going wrong. Now, if I need to use similar figures, here's what this means. It means that if they're similar, the ratio of their corresponding sides will be the same. So I can use that knowledge, that fact, to set them equal to each other in a what? What do I need to set up?
Proportion.
Okay, so go ahead and try to do that. The very first side that I want to write in my proportion is the side I'm solving for, PQ. All right, so PQ, and I drew an arrow to similar because this is all possible because these figures are similar. So PQ over its corresponding side. What side corresponds with PQ? JK. In the other figure, the same sequence of letters or side or angles, I guess is really what it is. JK equals, and now I have to go back to the same figure for my numerator for my second ratio because it has to match the other side. So since PQ is in the numerator, what other side length now in the same figure do I know the side value of? PS. Okay, so I know PS, and its corresponding side is what? JM. And that is the most difficult part of this, okay? So when I use similar figures to find unknown side lengths, I can set up a proportion. All right, now PQ is what I don't know. Over 36 equals PS, which is 35, over 21. 21x equals 1260, divide by 21, and x equals 60. I want to again point out that the equation that you write, 21x equals 1260 in this scenario, is very important, and without it, you are not going to get full credit. Again, I explained this in the proportion slide too. I'm seeing a lot of people just say 1260 divided by 21 and not turn it into the full equation. I need to see a full equation here after cross products and then see what you divided by. Simply put, I need you to write all of your work, show all of your steps, and you'll be fine.